This is Earth 250 million years ago, at the beginning of the Triassic period. It was a world so hot that what we call global warming today would have looked like a joke. Gigantic volcanic eruptions pumped carbon dioxide into the air, accelerating the greenhouse effect. The average global temperature rose to 25 degrees Celsius, 11 degrees higher than the 1961 baseline. In the tropics, peak temperatures reached 50 to 60 degrees Celsius. The ocean was basically a giant hot tub, with surface temperatures in some places reaching 47 degrees Celsius. The Arctic and Antarctic were so humid and warm that forests could grow there. Vertebrates, including reptiles, were giving birth and multiplying. There was no ice cap anywhere, no matter how hard you tried to look for one. All the land on the planet was locked together into one single mass, stretching from north to south, east to west. Inside the supercontinent Pangaea, most of the ocean's ability to regulate global climate was blocked off. The result was a massive planet that was extremely hot and brutally dry. And from that sweltering, bone-dry world, the ancestors of reptiles and early mammals flourished, dominating a planet still trying to recover from the worst extinction event in Earth's history 2 million years earlier. But then, when the gears of the Triassic had turned about one-third of the way through, 234 million years ago, something very strange happened. Earth's climate suddenly changed. Rain brought moisture to this dry, rocky, overheated planet. The problem was, it lasted for 2 million years. What? In the late 20th century, geologists discovered flood deposits dating back 234 million years. And during this super rainy event, many ancient reptiles were wiped out. The water-soaked period from 234 to 232 million years ago is known as the Carnian Pluvial episode, and it created the launching pad for the world domination of an entirely new group of animals. Dinosaurs. I bet a lot of you do not fully believe it when scientists make claims about something that happened hundreds of millions of years ago. When you look down at your feet, you see dirt and rocks. But geologists see clues about the planet's ancient climate. When scientists conclude that the early Triassic climate was hot and dry, it is because they found bands of red sandstone dating to the early Triassic. That red color comes from the oxidation of iron minerals in the soil, showing that it had been exposed to air under dry, low rainfall conditions. If it had rained a lot, the iron minerals would have oxidized less, and the rocks would have been darker. Beneath that, in rock layers dating to the early Permian, 300 million years ago, scientists found large coal deposits. Alongside them, mud cracks and ripple marks indicate alternating dry and wet periods, typical of the swampy environments where coal forms. Back to the main point. The main reason the early Triassic world became so dry was the shape of Pangaea. The supercontinent Pangaea formed around 335 million years ago from three smaller supercontinents, Gondwana, Euramerica, and Siberia. When all the continents were locked together, clouds could not travel deep into the landmass, leaving the interior without water and creating vast deserts. Dinosaurs already existed in this dry world. Niosaurus parringtoni, a species considered one of the earliest dinosaurs, evolved 243 million years ago. It walked on two legs, measured 2 to 3 meters long, had a large tail, and weighed between 20 and 60 kilograms. But there was still a very, very long way to go before dinosaurs truly became the big bloodline royalty of the planet. In reality, they were competing fiercely with ancestral reptiles and the reptile-like ancestors of mammals. The dominant animals back then were a group of crocodile-like reptiles, including pseudosuchians and phytosaurs. For example, one of the largest pseudosuchians living alongside the earliest dinosaurs was Mamboacale. It had a skull about 75 centimeters long, and its total body length is estimated at more than 5 meters. Saurosuchus was even 1.5 times longer than that, around 8 meters. Ornithosuchus, a species whose name translates to bird crocodile, had long, powerful hind legs and could rise up while running. If you think that looks ridiculous, now imagine it was around 2.2 meters long. Still laughing? Laughter. Even weirder were rhynchosaurs, a group of herbivores with parrot-like beaks and cheekbones so high that if they lived in feudal times, they would absolutely be undefeated cheekbone warriors. And although true mammals did not yet exist at this time, we did have dicynodonts, a branch of herbivorous animals with scales, beaks, and tusks, with Lystrosaurus as a famous example. They are thought to be distant relatives of mammals and were more closely related to us than to dinosaurs and the other reptiles living at the same time. All of these bizarre creatures were common through most of the Triassic. In fact, the discovery of Lystrosaurus fossils all over the world, from South America, music, Africa, Antarctica, India, China, and Australia, helped strengthen the theory of continental drift that geologists had been building since the early 20th century. But the animals that were perfectly adapted to this dry world were about to face a rainstorm that would change their fate forever. In the early 1990s, geologists found rocks that did not fit the dry climate of the Triassic. Instead of slowly deposited red sand, they found thick river stones, lake sediments, and even something that looked like a coal swamp. These were clear signs that rain had fallen continuously for 1 to 2 million years. Even stranger, this wet climate appeared to be present almost everywhere, from England and the Americas to Israel. These regions were far apart at the time, which means heavy rainfall must have fallen across the world. The rocks revealed cold deposits in Austria, ancient lakes in Italy, unusual wetness in the American Southwest, and enormous super rivers in China. Most importantly, all of them date to between 232 and 234 million years ago. Later, scientists named this period the Carnian Pluvial episode. Other names include the Carnian humid episode or the Carnian crisis. Carnian, in this case, is a stage lasting from 237 to 227 million years ago. However, if everything from the start of this video until now has made you think there was once a mud churning, sky darkening, nonstop downpour that lasted for 2 million years in Earth's history, then sorry for the misunderstanding. The truth is, there was no rainstorm like that. The 2 million year reign is just an exaggerated way of saying it. Or to be blunt, a flashy clickbait headline for an extremely humid period with heavy rainfall across much of the supercontinent Pangaea, along with annual floods happening everywhere again and again for 2 million years. For example, scientists estimate that the average annual rainfall in the region that is now Utah in the United States was 4 times higher during the Carnian reign, reaching a peak of 1.400 millimeters. That is roughly equivalent to the lower average rainfall of a tropical monsoon country like Vietnam. And this pattern repeated across most of Pangaea. But this rain did not just change Earth's climate. It also helped dinosaurs become the new dominant animals on land. At the beginning of the Carnian reign, dinosaurs made up only 5% of the fossils of land-dwelling vertebrates. But by the time the 2 million year reign ended, they accounted for more than 90% of the fossils found. So the question is, what made the dinosaur family rise to power so quickly? Dinosaurs did not survive by drinking rainwater. Well, they did drink it. But what I mean is, the dinosaur family did not expand by gathering around and chugging rainwater together for 2 million years. Right. Fair enough. The real reason was what the rain brought with it: the explosion of giant plants. The rains created the conditions for conifer forests and large plants, such as cycads, to sprout and flourish. And this sudden menu change left many reptiles unable to keep up. The main herbivores of the early Triassic, such as rhynchosaurs, were short. They measured from half a meter to 2 meters long, with an average length of only about 1 meter. Their main food was ferns, and ferns did not grow more than a few meters tall, so being a little short was not a big deal. But in a humid forest, even a flooded one, ferns were gradually being replaced by cycads over 15 meters tall and conifers that could reach an absolutely rude height of more than 30 meters. At that point, being short suddenly became a crime. Dicynodonts also ate plants, but they had no teeth, and they were not smart enough to swallow extra stones like birds do to help grind up food. Without teeth or stomach stones, dicynodonts would have struggled to chew tough, fibrous plants. In fact, dicynodont coprolites mostly contain soft ferns with a fiber content significantly lower than woody plants. Meanwhile, some herbivorous dinosaurs had both teeth and stomach stones, and their fossilized dung contains up to 85% fiber. So when the ground was watered for millions of years, tall, woody, green, sturdy conifers, which probably did not smell great, quickly overtook the small, soft, low-fiber ferns, the main course for dicynodonts and rhynchosaurs. And without the vegetarians, the menu for meat-eaters like pseudosuchians and phytosaurs became much, much poorer. So in that sense, the prosperity of the dinosaur family was not because of their superior evolution, nor was it a victory of absolute strength. It was simply because they were the only large reptile group still alive that could eat what grew during and after the Carnian reign. Those giant, fiber-rich plants. It sounds very convincing. But remember, this is only a hypothesis. The only way to know for sure would be to jump into a time machine and spend 2 million years watching the rain while doing research. The important thing is that, one way or another, dinosaurs really did become ridiculously numerous during and after the Carnian reign. Also around this same time, many reptile groups considered true Triassic natives, such as dicynodonts, rhynchosaurs, and many primitive pseudosuchians, went extinct. But one question remains. What could possibly kickstart a 2 million-year flood season? The answer might be pain. Oh, wrong. The answer might be a million-year volcanic eruption. Around 235 million years ago, a series of eruptions occurred across the Wrangell Mountains, in what are now Alaska, Yukon, and British Columbia. This eruptive event lasted nearly 5 million years, created a lava layer up to 6 kilometers thick, and released enough CO2 to raise global temperatures by 3 to 10 degrees Celsius. Rising temperatures caused more water from seas and oceans to evaporate into the atmosphere. After about 1 million years, the atmosphere became warm and humid enough for rain to reach the vast interior regions of Pangaea. But then, how the hell does a rain event just decide to stop after 2 million years? The answer is that our planet has 7 times 749 ways to pull carbon back in. Plants absorb carbon through photosynthesis and store it in their tissues. Rocks absorb CO2 through weathering and erosion. And oceans naturally absorb carbon when CO2 dissolves directly into the surface layer of water. When the Wrangell eruptions slowed down, the excess CO2 in the atmosphere was gradually absorbed back into the land and water. The greenhouse effect weakened, and the Carnian reign slowly came to an end. By the time the eruptive event wrapped up 230 million years ago, the climate on the supercontinent Pangaea had returned to the hot, dry conditions of the early Triassic. So, to wrap this whole thing up, the 2 million-year reign planted the seeds for towering conifer forests, wiped out bipedal crocodile relatives, and in the process, raised the dinosaurs, the group of creatures that would dominate land for more than the next 100 million years. Hopefully, this 2 million-year reign was enough to make you feel a little cooler. And if it was, please drop us a like as usual, subscribe to the channel, and ring the bell to get the earliest notifications from Wondrous Creatures. For now, goodbye, and see you next time. Oh.